sea ice now is important not just to scientists, but to a whole range of different people, different organizations, governments. The Arctic is changing very rapidly, but part of that change also very much takes place through the ice cover and impacts ecosystems, walrus, other animals that use the ice, people who hunt on the ice, companies that want to explore resources, develop resources that consider ice a major hazard. So what we're trying to achieve is expose a number of students from different backgrounds to the ice environment, so they learn more about how to work outside in the field, learn about field safety, learn about how to plan and design field study.
My name is Kevin Hilmer Pegram, and I study the human dimensions of sea ice. As everyone probably knows, receding sea ice is opening the Arctic, which is going to increase activity up here, industrial activity, tourism, shipping, oil and gas, everything like that. So what am I trying to get? I'm trying to learn how to think and work and understand the world in the way that natural scientists do.
So this was the top right? Yeah, right there. Try that. Nice!
Wow, yeah.
Okay, take a picture.
By taking an ice core, we can immediately reconstruct, almost out on the ice, what happened over the past few months or almost a year of the ice growth history by looking at the various horizons in the ice.
You can see this layer here is not straight, right? It's at an angle. You notice that here?
Yeah.
So this may actually be a piece of ice that got shoved under there sideways. So definitely this is very much in line with what you expect to see in highly deformed ice. And then
And so what you typically see for Arctic organisms that live in the nearshore regions, that they can tolerate temperatures up to about 10 degrees centigrade. And when it's getting then too warm, they basically die.
So one of the big questions is, how will the weather patterns on the northern hemisphere change with the loss of sea ice? Another big one is, how will the biology change in the ocean? Because there's an entire suite of organisms living inside the sea ice and in association with the sea ice, ranging from tiny bacteria to the seals that reproduce on the ice. And their entire life cycle is basically built around the presence of sea ice at certain times. So one concern is that these species might be harmed in their life cycles because of the non-existence of sea ice at certain time frames.
I am looking at juvenile salmon growth in the northeastern Bering and Chukchi seas. The extent and timing of sea ice melt is influential in the timing of the spring phytoplankton blooms, and the size and timing of the phytoplankton blooms really determines how much energy there is in the whole system. So I'm interested in how energy is carried up through the food web, because that ultimately determines the overall condition of fish species such as juvenile salmon.
Suppose one packet recording, and when it went up to 3 here, then you're done. Okay?
Yeah.
Good. Now you turn it 180 degrees down. You level it again.
And it's also important to realize that all these scientific disciplines are interconnected. One of our big aims is that we help educate the next generation of scientists that will have that interdisciplinary approach, whether they work on sea ice or the oceans or lakes or soils. I don't care, but I think it's very important to realize that in many disciplines, just staying within the disciplines is just not enough to tackle the current issues.